one of the programs I like the idea of being able to compile to is I looked at, so for example, I think even tools like Jira have their own rules engines. And I was helping someone and they were writing an automation and, they're trying to work out if a field existed on an event. So it was kind of event.ticket or something. There was a trigger, like a little lambda, but there was no help. And they asked me for help and I was like, okay, does the event have the banana field? Like, there's clearly not a banana field. But of course, it didn't fail any type checking. And then there's no logs in these systems either. So you didn't have a problem at runtime. So I was like, well, can you, it would be great if you could have an effect system for a platform that was just the rules engine in Jira or something really crazy like this. I think there are some programs where 5 lines of code is all you need, but there's a really interesting environment that it lives in. So that's what I want EYG to really kind of champion.
Welcome to Software Unscripted. I'm your host, Richard Feldman. Today I'm talking with Peter Saxton, creator of the EYG programming language, which is short for Eat Your Greens. EYG takes inspiration from a number of other programming languages, including Rock, the language I've been working on for the past few years, as well as Unison, Gleam, and others. We talk about the problems Peter aims to solve with EYG and some of the unique design decisions he's made with it. I want to give a massive thank you to everyone who's been supporting Software Unscripted on Patreon. If you enjoy these episodes and you'd like to become a supporter too, check out patreon.com/softwareunscripted. And now, the EYG language. All right, Peter, thanks for joining me.
Yeah, hey, thanks for having me.
So you created this language called EYG, which, as I understand it, is short for Eat Your Greens. And it seems like the most notable 2 influences that I see in the language, and correct me if I'm wrong, it seems like it's Rock and Unison. Do I have that right? Or would you say there's other things that are sort of more strongly influential on it?
I think that's fair as the influences. I come from a lot of the Gleam development, and I guess some problems I found over there. But yes,
interesting.
Rock and Unison are definitely key inspirations.
So what are the specific problems? Because I know whenever someone creates a language, it's very often, if it's intended to be like a production language as opposed to just a toy just for fun language, a production language seems like people have something that they want to exist that doesn't exist in the world. So I'm curious what that was for you.
Well, for a long time, I avoided being a production language incredibly hard. So it lived in a repo in a folder called language. And I very carefully only ever called it my language. So you couldn't find it. Like, you couldn't give me issues because I didn't want them. It was an experiment. It was experimental space to push things which I wanted in Gleam, because I think Gleam is a perfect language in a lot of ways. But you hit the edges. Like functional programming has this problem of, well, how do you serialize JSON? It's ugly, or there's just a lot of stuff going on there. And I really wanted to sort of expand the scope of what you could do. So for a long time, it was experiments with effect types, for example, which come in Unison and Rock. There was also the content addressable AST, which you could send to and from places. But a lot of these things were built with this is my test bed to put them in other languages. Like, I didn't want to run a language. But I've now got to the point where actually it's a thing on its own. It has a different use case, which we can probably get into. And so I now think it has a place, and it has these features which are structural typing, effects, and they make a unique and different whole, in my opinion. So it now has a name.
Yeah. So some of the things that I noticed that I was like, oh, Rock does that, were the anonymous algebraic data types. So like in Rock, we call those tag unions, and I think you just call them tagged unions, which is, of course, where the name tag union comes from, because that's what they are at runtime. And then also you didn't call it like platforms and applications, but it seems like you have a similar goal of sort of not tying the language to a specific runtime or compilation target, but rather it can target a variety of different things. Whereas Gleam, I guess, was originally just for the Beam, and now it's for Beam and also JavaScript. And it seems like targeting multiple different compilation targets is a goal of yours from the get-go.
Yeah, absolutely. I mean, I talk about people being able to build an interpreter for my language in an hour or something, because it makes zero assumptions about the runtime underneath. So maybe you'd have a very slow interpreter after that hour. But again, I was pushing things very hard. So there was a point where installing the language was just an instruction on how to write an interpreter. Like, this is the AST form, like, write your interpreter. Because for a long time, the language had no syntax. Like, I would write the AST by hand because I was interested in building type checkers and these things. So yeah, like, having it portable, it's why I know Rock very well, because I've looked into the platform's stuff. I think I don't know exactly how close our philosophy on these things are. I know Rock does a lot of stuff on performance, whereas
Yes.
I'm happy to throw that entirely out of the window because there are programs. One of the programs I like the idea of being able to compile to is I looked at. So, for example, I think even tools like Jira have their own rules engines, and I was helping someone, and they were writing an automation, and they trying to work out if a field existed on an event, so it was kind of event.ticket or something. There was a trigger, like a little lambda, but there was no help. And they asked me for help, and I was like, okay, does the event have the banana field? Like, there's clearly not a banana field. But of course, it didn't fail any type checking, and then there's no logs in these systems either, so you didn't have a problem run. So I was like, well, can you, like, it would be great if you could have an effect system for a platform that was just the rules engine in Jira, or something really crazy like this. I think there are some programs where 5 lines of code is all you need, but there's a really interesting environment that it lives in. So that's what I want EYG to really kind of champion.
Yeah. So in Rock's case, I don't know Jira's system specifically, but you certainly could do something like that in the sense that a Rock platform does define, here are the primitive effects that are available in this platform. However, you're right that Rock runtime performance is a big priority for Rock, and so we support that, but only if that platform exposes a C or WebAssembly API. Like we compile to either machine code or to WebAssembly. So I don't know what Jira's format looks like. If there's some way to get it into C or WebAssembly, then you're good, and if not, then no, that wouldn't work as a Rock platform. Yeah,
because I think you're going to like those formats, whereas I'm making it that from the AST, like the whole backend is a simple thing to produce. The AST is deliberately, I think I'm on about 20 AST nodes right now. So, you just, you sit down and you have a switch statement with 20 branches, and at the end of it, you've implemented the whole language.
Right. So the idea is that, setting aside performance, like you said, out the window, the idea is that if you want it to run somewhere, it's as easy as possible to do that because you can just sit down and write an interpreter for it. And again, interpreter, the downside is performance, but like if you're not worried about performance, then you can target pretty much anything and be kind of as flexible as possible.
Yeah, and I think the performance is an interesting thing. I don't know exactly how far you can go down fast interpreters, but if you ship the AST as the product, there can be a compact binary format of that. So there's no parsing or lexing. It's already which makes your editor become the compiler, which is an interesting kind of step because it ships out something that is still got enough source information to you open it in another editor, but compact so that if you run it in interpreter, it's faster than parsing Ruby from scratch. So I think it might be an interesting middle ground.
And I guess someone who is building a sort of backend for this, like let's say the Jira use case, in theory, they could, if they have the ability to do this in their particular scenario, they could make a JIT for it. And they could say, like, this is I've got this AST, I'm going to interpret it, but I don't have to interpret it straightforwardly. I could incorporate a JIT into all that. Now, you need a separate JIT for every different instance, I suppose. But you could do that if you wanted to.
So I have a transpiler to JavaScript, and then you're now back to JavaScript performance, which,
right.
So they're a bit harder. An interpreter is one of those things that I think is almost a boogeyman that, everyone should write an interpreter because actually the easy ones are very easy. I think that's not entirely true for transpilers. There seems to be more than one issues that show up.
Right.
But you can, there's nothing stopping you adding more. Like you can do more passes over the AST. It's just for your environment. And I am kind of fascinated by all these different environments. So the last place I was working with industrial control software. And this language isn't going anywhere near that anytime soon, but we had machines in a factory that received 1 request an hour when the big machine finished and was like, here's some JSON, which says what we've made. I'll send another request in an hour. Like there's no performance issues there. We did it in Go, which was quite performant, but we were, I'd like to think probably 10 orders of magnitude over what we needed in terms of computing power.
Right. Not a performance sensitive use case. And there were plenty of use cases like that where, or like a small script or something like that, where you're just like, I don't really worry about that. So what about numbers? Because one of the things that I've thought about, because a thing that people ask about periodically is like, hey, can Rock compile to JavaScript? And one of my concerns there is that because we have this performance focus, we give you basically the full, I guess there's theoretically there's an infinitely large amount of numbers you could support, but we do like 8-bit, 16-bit, 32-bit, 64-bit signed and unsigned integers, and then we have 32 and 64-bit floats. Then we also have our own fixed point decimal type, all of which are used in different situations. Whereas in JavaScript, it's like you got floats, like 64-bit floats. That's it. That's everything. And then you also have big int in JavaScript, but that's like heap allocated and has much worse performance. Whereas something like Java, if you're on like targeting JVM, you have all of the integer sizes that I just mentioned, except for the unsigned ones. But if you're targeting C, then you also have the unsigned ones. So there's this big world of numbers out there, and I'm curious. I guess you have to go for some sort of lowest common denominator. I'm guessing just like int and float or int and fraction or something like that, or how do you think about that?
Well, so I think for over a year I didn't have any numbers at all. And the standard library had a field called 1, which was .one, and another field called 2, which was TWO, because I needed them for examples. So one, they didn't exist. They were a platform-specific thing. Because, yes, there's a lot of opinions around numbers. And I really wanted to start with a framework that was pretty much without opinions, which I think is not a helpful goal. So at the moment, I now just have big integers. You know, they're numbers like any human who's not a programmer can add, you know, string down 100 zeros and it just be slow and not do something unexpected. So I very much start from a place of, I want you to start from something like entirely predictable. So it's Erlang has this as kind of base layer. So that's an interesting one that they do have big ints as a start. I definitely am going to need floats. Like there's no doubt about that. Like I've currently integrated with a geo coordinate. So you get your latitude and longitude, and I have to deserialize some JSON, and I have to write a special deserializer that times the data by 1,000. So it's an integer number of thousandths of a degree around the planet, and that's not helpful. But
so
yeah, I won't have different sizes.
Okay, got it. Are you envisioning like a package ecosystem in the future, or is it kind of intended to be for like one-off projects? Because like one of the things that we thought a lot about in Rock was like, how do you share code across platforms? And part of like one of the complicated questions there is how do you share effects across platforms, which we can talk about that. We have an answer to that we're working on. But then even beyond that, there's like, how do you share code across platforms that doesn't have anything to do with effects? Like, for example, you have like a hashing function that's like, just give me some bytes and I will hash them for you and give you back a number. Something like that you certainly could implement in, you know, non-effectful code in EYG or in Rock. But that's a situation where the number representation that the platform is using, I would think, would make a pretty big difference because, like, for example, in hashing, you do a lot of stuff with like bit shifts, and you have to decide, like, are we doing 64-bit integers and stuff like that? And I guess you could probably limit it by saying like, we're going to do a bit shift with that like wraps at a certain bit width or something like that. And so even though you're a heap allocated big int, you could still like tell it to, on a case-by-case basis, pretend it's 64 bits or something like that, or cap it there. Or I don't know. I don't know if you thought about these things or what your thoughts are.
There's definitely there's a few like versions to this. At one layer, I'm actually very keen for people to use effects to reach into other parts of the system. So, you know, we talk about having a platform which is, okay, maybe like it's a Linux server, but actually, you know, I think if you were to use EYG in bigger systems, like the platform could be very business specific. You know, you could have, you know, not just your kind of LLM and your current AI stuff, but, you know, if you need things faster, put them behind an effect as the go-to thing. And so you can have, you know, you can now start sharing code which goes, because the nice thing about effect types is when you get a piece of code, you know what effects it might need. And so it'll say, I need an effect which is called hash, which takes a number and gives me so it always advertises that it needs that. So there's nothing stopping you just putting more like things the other side. Like, you know, I'm hopeful that there might be kind of quite a big ecosystem of runtimes. So embedding EYG in Go or Rust or Zig, they all exist. And you kind of have it as like, I've toyed with the idea of calling it a rules engine more than a language, because you always get this business layer where you kind of configure stuff, and there's always this orchestration layer over faster machines. And I really want to start from there and go down. But I guess that's not kind of the programming language answer. One of the things which I think is, you know, EYG taking more mind share is types to specify the lengths of binaries. I think that would be quite interesting, because I would be, you know, they do exist. So you can say this function takes a binary which is 4 bytes long. And then, of course, if you have a library of things that work on those, that is a library that works on 32-bit ints. So if you can have efficient bit arrays or binary in the language, you can kind of natively write things for all these different sizes of integers. I mean, it's not fast enough if you have a machine instruction to do things with, 32-bit ints, but it's still probably quite fast, like if you have fast binary operations. And there's also a trick where you can, because there's hash references to code, you can recognize code, which is like the native code for creating a hash, and actually have an interpreter that goes, no, when you call this function, I've got a sneaky faster version that I can throw in instead. But yeah, I don't want anyone to be able to break the effects to like faster FFI, because I want the kind of top level guarantees of like, this will not do something it doesn't say to be totally cast iron. And then you kind of, the effect might be, I call this fast C thing, which is really unsafe, and I take the answer and I send it to this fast C thing, which is really unsafe. And as long as they do what they say, I'll do, I'm going to do what I say, but there's no escape valves to make EYG faster.
Right, I see. So you basically have a concept of FFI, but it's entirely behind like effect types. So if you're ever doing FFI, you know what it is, and also the FFI is not something that application authors build. It's more that whoever's building the runtime for your particular target, they're in charge of that FFI. And if they want to expose that in user space, they could do that as an effect, I guess.
Yep.
Is that right? Yeah.
Yeah, and there's a real example I had, which was so I used EYG to make some websites, and I ended up doing stuff with content editable. Like I was trying to make a rich text editor component. It just wasn't worth it. So actually, as an application developer, I was like, okay, this is a piece of JavaScript that just needs to exist here. And so I had effects in the language. I can't remember what they were called, but they were effects for kind of like, await next text input, and so on and so forth.
Yeah. Yeah, one of the tricky parts about that is, I guess, I don't know how the effect system works in EYG, but at least in Rock, so you have task as its own type. Like, we don't do algebraic effects. It's just like you have a concept of a task, which is kind of like IO in Haskell, or a task in Elm. And so your entire program is generally built up of one giant task composed together of other tasks, or maybe kind of like promises, but with built-in error handling, unlike promises. Or, I don't know, built-in error types, unlike promises. Yeah. And so that sort of like builds up through your program. But if you're in the middle of a long string of these things and you're like, if you're in the middle of a long string of non-effecty things, for example, mathematical thing, and you're like, I want to do a hash right here, and hashing is an effect, then now you need to go back and make everything up that whole call chain use the effectful thing. But I don't know if that's the case in EYG. Is that accurate or no?
No, well, I think I've not looked at how rocks move to task, but I think that no, you don't have any function coloring problems. So the effects compose completely. If you do list.map and you take in a function, that'll transparently take care of the fact, like if the function that does the mapping wants to raise completely arbitrary effects, the list.map doesn't need to do anything about this, and you can write. This could be handled all the way at the top level of the program. Like you can use a library that uses an effect. Your whole application never sees it. Your runtime will then either have to provide that effect. I mean, you can handle it and you can inspect it, but there's no composition issues, which I think was what you were maybe alluding to.
Well, not about the composition issues. I mean, that's a separate issue, but which also is definitely a thing. Maybe a better question would be, so in the list.map example, you're saying, so you call list.map and you pass into list.map a function which does some sort of effect. I guess two questions. One would be, does that change the return type of list.map such that now the call to list.map is itself effectful?
It doesn't change the return type. So the type checking system runs over like every single value has like its value and then the effects that it records in creating that expression. There's no change.
I guess maybe a better way to ask it is like, does it propagate? So for example, if I have a function that's calling that list.map, does that function's set of effects change depending on whether or not I pass an effectful thing to list.map?
Yes, absolutely. So like the type of list.map is it's a function that takes a list of A's and raises the effect E, and it also then takes a function which it takes in an A and then itself raises an E. So it's polymorphic over the effects that are raised. So if you pass in a pure function, then that the top thing is a pure thing as well, because you can have no effects.
Got it. So then the follow-up question would be, let's say I have a long series of call chains, and I mean, so effects are something that you annotate in the source code, or
No, so there's a perform keyword. So if you want to go to the lowest level and you just want to perform a log effect, for example, you just call this perform keyword and then it gets a label. So the effects they're just labeled. The whole thing is essentially another tagged union setup. So the effects are, if you perform log, you say this code now has log, and then it unifies the argument you pass it in, so you pass in a string. So this the effects have a raise and a lower type. So it'll be keyed with log, and it'll say lift string and lower unit, or like empty record, because there's nothing back on a log.
Well, so let's say that I have a function and I decide to, like it's in an existing code base. I've checked it into Git, and I say I'm going to do a perform log or perform HTTP request in the middle of this function. Does anything else change about my code base except for that one line? Like,
no.
let's no. Okay, so you don't annotate on a per function basis which effects the function is doing.
No, so the language is entirely inferred, so there actually isn't the ability to annotate functions. So yeah, no.
Oh.
Yeah.
So not with type annotations either.
No, there's no type annotations.
I see.
If you use the structured editor, you can walk through and it'll show you all the effects of any given function. But yeah, there's no annotation that it matches.
Interesting. Now, is that a design goal? Is that like you'd rather not support type annotations, or is it like falls out of other design decisions, or?
It was a design goal, one that I'm thinking of potentially walking back from. For a long time, I had the design goal of, so I've been very interested in end user programming. So these slow programs, the person who set up the Jira board, like it wasn't the programming department that did it. It was just, they got in trouble and they asked the programming department. And so one of the design goals I was looking for was, I want you to not have to define an effect before you use it, or any type. Like types are something which help you. And this is kind of where the language name comes from. The whole EYG thing is, if we're very, eat all our vegetables, what benefits do we get? So if the AST and the type system is simple enough that we can always infer, then the benefit is that we can always help you out, kind of thing. So, I mean, yes, there are definitely problems with not annotating. Like eventually you have a type error that shows up a long way away from what you actually don't want. It could be an editor tool that you kind of say, pin this function to return this type, and doesn't become part of the source code. But it is helpful. It is a very helpful debugging tool to be like, no, I want to tell you about the effects that this function has.
Well, to me, it's partly about debugging, because you can get nicer compiler error messages and things like that. But the other thing that I like about them is just when I'm reading the code, I appreciate having a form of documentation that I know has been verified to be accurate, unlike comments, which could get out of date and, who knows how accurate they are anymore.
I was just going to say, if there's a world where people start leaving this like effect type in the comment, then I've failed and I need to just put type annotations in there.
Yeah, well, I don't know. I mean, algebraic effects are pretty new, and so the idea of having like the individual effects that happen appearing in the type is something that I think is relatively unexplored. We briefly tried it out in Rock. So there was a while ago, that's not the case anymore, but the task type used to be something that each platform defined individually. Now we have it in the standard library, but before, for various design reasons, the platform itself would define the type of task. And one of the things you could do, if you wanted to, was you could have task, instead of having two type parameters, one for success, like what happens if it works, and one for errors if it fails, which is what we have today. We experimented with having some platforms define a third type parameter, which was, what are the actual effects that this is doing? In other words, like, am I doing a network request? Am I doing a, just printing the standard out? Am I doing file reads? Am I doing file writes? And as you would call these things, it would propagate similarly to what you're talking about, except that, and also be based on type inference. So you didn't have to write the annotations, but it would kind of know. And essentially what would happen is that at the end of the day, your program would, if you did choose to annotate these things, your program would have pretty long type annotations for anything doing effects, especially anything that was doing a bunch of different effects. And then if you wanted to add one more effect, you had to go change all the type signatures to add to all of them in the intermediate call chain. And at the end of the day, it just didn't seem like it was pulling its weight. It seemed like it was a lot more bookkeeping than was worth it. But that was in Rock, and different languages are different. They're used for different things. And so I don't want to say that it's like, no language should do that. It just didn't seem to make sense for us. But I'm curious if you thought about, like, if you do decide to add annotations, would you definitely do it for both types and effects, or maybe just one or the other, or what are you thinking there?
I think if I needed to add them, it's like, I would be surprised if there's a world where you only need to add one or the other. But I mean, I'm not a massive fan of type annotations as much as possible. I do think that you're right. Like the effects in particular accumulate, and yes, they they are very invisible at the moment. That you can,
Sure.
like logging is a great example. Like it would be a terrible thing to like put a debug log in and have to update the annotation for like 3 places that it uses the debug log. Like if you're in an environment that has a logger attached, you're not going to care that much. Kind of, it's there's some nice kind of the functional purity. When people talk about the imperative shell and this functional core, this idea that you should have nice pure business logic in the middle. It sounds nice to really start policing this, but actually it seems far more true that once I've been using effects, that if the effect handler exists, like if I have this ability, I kind of want to use it everywhere. It's just really helpful that if I don't have this ability, I'm in an environment that's not got fetch, or I've got a, one of the nice ones is because async await is now in effect. I can't have asynchronous code in a click handler in JavaScript, but you can in the web worker. So yeah, I think having a lot of them and having them fairly transparent is the value of, certainly with what EYG is becoming. I think that seems to be like what's been useful so far.
Yeah, that's really an interesting example of the like click handlers in JavaScript. You can't make them be async for, I guess, security reasons, if I remember right. Or well, in a lot of cases, there's certain operations where they have to be done synchronously inside the click handler, or else it's assumed that you might be trying to do something nefarious. Like I think clipboard operations are like that, if I remember right. It's been a while since I've used those APIs, but yeah, so I guess it really kind of does depend on your target platform, like what you could use those for.
Yes. And the JavaScript one, it's as much a UX thing as well. So I gave a talk about, so Gleam has this interesting dichotomy between the Erlang and the JavaScript runtime, that one has promises and one doesn't. And people don't like that you have to use different libraries for like HTTP fetching, because, in one of them you get a promise, in the other one you don't. But my argument was it's actually a feature of where you are. Like if you're writing Erlang, you're on the back end, and your web request can be asynchronous, and that's a feature of your design space. And if you're on the front end and you've got a user click interaction, you need to put the promise somewhere else, or you need to like update the screen the second they click it and deal with the promise later. Like it's a feature of where you are. And I actually like the type system reminding me, there's a common library for building requests, but the library for sending requests, one of them has promise and one doesn't. And I think it's a good thing. I think it really tells you where you are, and you can be part of the design space.
Interesting. So the backend one is synchronous and doesn't use a promise, or is asynchronous and doesn't use a promise, or how does that work?
So the backend one, so this in Gleam, if you use the Erlang HTTP libraries, say like HTTP send, it takes a request and it returns a response. Whereas if you use the JavaScript fetch library, which is in the compiles to JavaScript, it takes a request and it returns a promise of a response. So you can't use the same code around it.
Got it. Yeah, that makes sense. I mean, that's another good example of I don't know. People say like, why not just compile to blank? And it's like, well, there's a lot of edge cases, a lot of like considerations to that beyond just like, can you get hello world to show up in that environment? Yeah. So another question I had was around how you think about strings. So numbers can be different across targets, and strings can too. And one of the things I tried early on in Rock was to say, we're not going to define an encoding for strings. We're just going to say they're Unicode, and that's kind of it. And we tried not to, I mean, they were stored as UTF-8, but we tried to keep that as much as possible as sort of an implementation detail. But one of the things that kind of kept coming up is like, well, and again, maybe this was all performance stuff. I hadn't really thought about like which of those design decisions broke down into we're doing this for performance reasons versus not. But a thing that pretty early on came up is wanting to like traverse the individual UTF-8 bytes, because if you're doing a parser, that's kind of exactly what you want. You don't want to have to split them into Unicode scalars or grapheme clusters or something like that. That's just a lot more expensive. And if you're going to be parsing anyway, you probably don't care about those 99% of the time. So there was this whole sort of giving up on that as a design goal, because it was like, well, like people are going to end up coupling their code to UTF-8 anyway. But I guess if you're targeting lots of different systems, then you have like JavaScript does UTF-16, or like a variant of UTF-16, I guess. Well, it used to be UCS2, and I think now browsers standardize on UTF-16. And Java has, I think it's UTF-16, except there's like one slight difference regarding how zeros are handled or something like that. And then, of course, like WebAssembly doesn't define it, but then like usually if it's C or C++ or something like that, it's probably UTF-8, unless it's on Windows, in which case it's WIDECHAR. And So it seems to me challenging to try to write a string library that deals with all these things. But maybe if you're not thinking about performance, then you can just kind of say, yeah, we just deal with like Unicode grapheme clusters and that's it, and don't worry about anything smaller than that. I don't know. What are your thoughts on that?
Yeah, essentially, you can, if you do it slowly, you can ignore all these things. Is where I'm at. I think.
Okay.
Yeah, that is the answer. That I do it incredibly slowly. And that's what happens. I mean, extending the built-ins, or the effects, like you can have an effect for like dude graph me or something, again, quite easily. So you have the escape valve, which is always the same one, but no, the language is slow with strings. I haven't dived into that rabbit hole. It took me a year to add the number 2, so I think dealing with UTF-8 strings is going to take me a bit longer. Yeah.
Well, let's be honest. I mean, who needs 2? 0 and 1 is really all you need. I mean, just hand wave. The rest is left as an exercise to the reader. It's all good. Yeah, that makes a lot of sense. I think it's an underrated design goal to be thoughtful ahead of time about what your sort of performance goals are. I get frustrated when there's sort of too much hand waving around performance in either direction, in the sense of saying like, well, we're starting off with this thing being designed this way, and then someday we'll make it fast using magic wands or something. And then eventually it's like, oh, actually, we can't because of design decisions that we made. Versus if you're saying like, no, like the priority is portability, and we're explicitly saying we know that things are going to be slower as a result of this, but that's not our design goal. Our design goal is to be for use cases where you're not really concerned about performance, but you are concerned very deeply with doing things in exactly the way that makes sense on this particular, Jira or like whatever environment the case might be.
Well, I think people need to being explicit about your performance goals is really important to not like disappoint people. Because one of the things because things get so drastically small, you have a binary form, it gets faster than the average interpreted language. So I want to tell people it's fast, but I know that's not helpful to them, because when they say fast, they mean like fast, like blazing, and it's not doing that at any point. But one of the fun kind of other spaces is, the content addressed ASTs. So that's kind of the other key feature of what makes it. So you have this ability to content address any piece of code. You also have an understanding of the side effects of any piece of code. So you can use content address storage as memorizing the type inference. You can look at it and say, oh, I've memorized the type inference and this function is pure. Well, I'll just memorize the answer. Like I never calculate it twice. And because there's ways to, like, all values are actually representable as code. Like if you get an array of numbers, it could just be the AST for an array of numbers. I can memorize values as the AST that would create them, like the smallest AST that would create them. You have this kind of version of super compilation. When you run through a program and you take all your runtime values that have come out, you capture them, is what I call it, back into AST code, and you put this all in a great big database of hash reference code, and you never calculate them a second time. So this is definitely where this is one of the things that's intrigued me about where I've got to is this. So code notebooks are a fun environment. I like Code Notebook. They're good for a lot of people. But Code Notebooks have this problem, like if you change the code, should you reevaluate the code afterwards? Because maybe it's not the same. But you don't know if it might, fire the missiles. But of course, if you have effect types, you 100% know. So I've now got this kind of Code Notebook space where the top level declarations are all pure. Like actually they can have the abort effect as well. So you can do stuff. It's really useful to say like pass this email address and then you put in the actual email address. It's never going to fail, but the type system says the abort effect is possible. So I let that one slide. And going through the Code Notebook, like you can have a line of code, and if you say like let x is the number 3 called with 3 arguments, like it's totally invalid code. We know that was never ever going to be allowed to have an effect. So you can just crash on it, skip, and then carry on executing the program. Mm-hmm. So you've working in this Code Notebook is incredibly fast because it just does the minimal amount of work pretty much all the time. And then if you ever want to do anything effectful, you have like an explicit like call button next to it, and it then starts looking a bit like a shell because your shell is very imperative. Like when you run deploy or FTP push, your shell is very like do it. You have this Code Notebook, which is all the code definitions, but you can use full programming. So you can do like almost like meta-programming to like look at a JSON schema, generate the API requests and stuff. But then you have this like fetch button, which is incredibly explicit. But the whole thing is just not doing very much work. If you read that JSON schema, it's just memoized into the notebook by default. And so you get this whole other like kind of space of like doing small amounts of work. Like, if stuff is over very large databases, but quite simple, you can be quite clever about, well, I've called this function with this argument. There's a million items in the database. I've updated 3, and you only do 3 of the million pieces of work again, kind of for free. And then, of course, there's no beating that with any efficiency on the other side.
Sure. Yeah, that's really interesting. I thought about, so I know Unison does something somewhat similar in the sense that I know that they do the content addressing of functions and storing those locally. One question I would have is, do you also do the thing that Unison does where when you compile, you're sort of always like adding to or getting things out of that local content address database, as opposed to typical compilers are like, start with the source code, maybe we have some stuff cached, but the source code is sort of the source of truth, whereas Unison's more like, actually the source of truth is the database, and if you want to take the source code you've written and add it to the database, you run a command line operation or something like that, or maybe you have a watcher going, and then the database is sort of driving everything, as opposed to the source code driving everything. Do you have something like that, or is it more like the traditional start with the source code and then this is all just sort of caching?
Yeah, it's definitely source code first. Like you very much have the source code and then the stuff is caching. And yeah, if you've, or because you have, I don't think Unison I think it targets more than one target right now, but it doesn't target like the dozens that I'm going for.
Sure.
The simplest interpreter or compiler is to not have to also build a kind of database access caching layer. You can definitely start the source code, ignore that there is actually an ID for all these AST nodes and just like work through it. It's just that the kind of the language that I'm like, a lot of the discussions around like what am I actually making part of the library, like the AST is what I share, so the AST is a public API. I haven't yet shared the actual sort of hashing algorithm that I'm going to get behind this, so like this is the official EYG hash of everything. Like I've got it in one of my runtimes, but it's not yet out. But it's a kind of another feature you could pull in. You could kind of go, yeah, this hashing is available, so if you care about adding it to your runtime, like this is the kind of, approved library for how we do hashing in ASTs. And obviously you need to use the same hashing format to have a big distributed database. But, there's these kind of Web3 IPFS visions of no one ever computing the same thing twice. Well, a lot of stuff is quite cheap to compute, and we have really powerful computers here. So maybe I shouldn't trawl the entire planet's database to see if they've added these two numbers together before.
Yeah, that makes sense. I always do wonder about, and I guess for a language that's not targeting runtime performance as a goal, maybe this makes different amounts of sense. But one of the things that I thought about, because I thought about these sort of things for Rock, especially in the context of running tests. So although we don't do content addressed hashing of like individual functions, we certainly can do that for modules. And this is the current plan for how we want to do incremental compilation is say like, we have a hash of the contents of your module, and then also a hash of all of its imports recursively, etc. So we know that at least at the module level, if you didn't change any of your modules, then we know exactly what's going on with this module, and we sort of know what it is. But if any one of its dependencies changes or it changes, then potentially things are different. And a thing we can do is we can say, well, tests in Rock that are like pure functions, not doing any effects, then we know that those are all going to either pass or fail based on 100% just what was the source code like. So we can just say, if we already got the answer to this test, don't even bother rerunning it. Just cache it somewhere and then be like, yeah, done. No need to rerun that. But that's not quite the same thing as like trying to skip evaluating individual values. For us, that's something where it's more like, well, if we know based on the source code that this value is whatever it is, we want to try to do that in like an optimization pass, which we would basically do on every single rebuild, at least when you're passing the optimize flag. But that's not something that I think we would try to like cache in the same way, if that makes sense. But I don't know. Like I guess that gets into a question of not runtime performance, but compile time performance. Like, what are your thoughts on that? Is this compile time performance a big goal of EYG, or also not kind of sort of out of scope?
No, I think compile time performance is, in my mind, more ways it can kind of like order cubed go wrong. So I want to make sure that that doesn't happen. One of the things that I don't know exactly, so I don't know if Rock, when you talk about the test at a module, like you have this module boundary. EYG, actually everything is expressions, so there's no modules as such. If you for a long time there wasn't any sort of package management, and before I invited anyone else to play with it, all the source code was in one AST. And the wonderful thing about this was, if I ever updated any of my library code, the type checker would tell me if I was misusing it anywhere in any code I had ever written. This kind of glorious, global view on stuff. And so then I introduced these hash references, so you can reference other bits of code, and that's how you pass them around. And it's a really kind of intuitive way. It's kind of like you can use the clipboard now, rather than, there's no package manager. You just have these hashes. But essentially, outside of these hashes, there's no other boundaries that I have to slice compilation up on. So I need these hashes to be memorized to some degree, so I can do incremental compilation. Because I think if Rock is able to do smart things and go, okay, this is a test function in this module, okay, I can do clever things about this module. But we don't have modules. It's just another let statement. It's a let statement that returns a record. So if things look like it's got a, the standard library is just a record which has got a field called strings, and inside that strings there's just more fields which are called like reverse and uppercase. And so you need to kind of hash break it up so you don't, reinvestigate these every single time.
Interesting. So, okay, so now I have a follow-up question, which is, I think of modules as a really valuable language construct, and for the particular reason of information hiding or implementation detail hiding, I suppose. So for example, if I'm making a dictionary, I might want to say, look, I don't want to publicly expose what the hash function is because I don't want people to depend on that, so that I can upgrade the hash function in the future without breaking them. Now, this does require the dictionary to be ordered, because otherwise just traversing it allows you to indirectly depend on the hashing function. Yep. But the way that I would do that in the language of the module system is I would say something like, I'm going to declare an opaque type that is dictionary, and then inside it, there's the implementation details, and then I expose functions that are exposed outside the module, but then there's also some internal functions to the module that are not exposed. So how do you think about doing something like that? Is that just not intended to be supported, or how do you think about that?
Well, this is, I think, quite an interesting sort of discussion, because I don't intend to support any of this, and in a lot of ways I can't. So because there's no type declarations, you can't declare a type as opaque. That's not a concept that exists. It's just structural. If you get something with these fields, you have something with these fields. And again, this comes slightly from this, we can sort of talk about end-user programming, which led to some of these choices. But I'm really kind of turning on its head package management with these. So if you have a hash which behind it has a record with a load of functions in for, say, a map, and it has a hash function and so on and so forth. If you want to use that right now, you've written that code locally. You email me the hash. It's in our shared database of hashes somewhere. So I reference that hash. So I don't know what you put in that code. But if you ever change that code, there'll be a different hash. So the hash that you've given me is a hash forever. It's a hash reference address. So if I use any internal details, if I use the hashing function, it doesn't matter, because it will never be taken away from that particular hash. That hash references incredibly specifically this implementation. Every implementation detail is stable forever because you've used hashes. But then you move the problem to okay, so how do I communicate upgrades? How do I communicate that there's a new version of this code? And there's an interesting question of if you make a new version of this map, why do you want me to upgrade? If my program's running fine, why do you care? And if I do care, I can subscribe to your blog, and on your blog you can be yeah, here's a new hash for my latest program, right? And you go, okay, cool. I like this guy's hash maps. I'll pull in the hash, and as soon as you pull in that new hash, you'll kind of have a diff in your code, and it'll go, yeah, this type system it'll fail on the type checking on that thing. So I think there's a kind of meta problem that will arise on authoring strings of hashes. You'll have this kind of the equivalent of a Git history for these hashes. I'm calling it, Richard Feldman's hash library, and
sure.
version 1 and version 2. But so I talk about having these languages be incredibly portable. I talk about them being incredibly portable through time, because there's no dependency on the computer. You've entirely got rid of that. There's no C ABI changing. I've avoided the things with numbers, and I've used big int. So if we have 500 years into the future, with a book on lambda calculus, you should still be able to run these programs. And that hash, just if you have that hash and you like that, yeah, there's nothing else going on. There's no like you're out of date. And the security vulnerabilities and everything is, it's another interesting conversation. But as we have supply chain attacks anyway, I'm not sure that giving people the ability to just bump a semver number has also solved it in any great way either. But yeah, but if you optimize for this stability, like if you have a hash to one of these programs, you can look at it. You can implement the type checker from scratch because it's written down in English language somewhere. It goes, it needs these three effects. If you write an emulator which gives these three effects and these three, you will slowly get through the program. And the wonderful thing about the implementation with everything being interpreted is, so actually I have, what's it called? It's called closure serialization. So you can take a closure from your program and reserialize it, and you'll have a hash for that. So actually, if you raise an effect that you don't handle, you have a hash reference to the AST from the program from that point on. So you could just pick it up later. So when I say these things, so I have on the page for a while, like with no errors, like you have no unrecoverable errors ever, because any break case in the program gives you this resumable artifact, which is another AST, which will tell you that it's a function of weighting this return type from some effect. At this point, you'll have lost the label of, well, actually you won't. It's out of the program at this point. But you just get this bundle, which is, so I'm waiting for the answer for the foo effect. It needs a record with three fields, A, B, and C. The first two are integers, and the last one is binary. I'll carry on when you give me one of these. Like, write it on a stone tablet. It'll still, it's kind of that level of like durability is theoretically possible.
Okay, that's really interesting. All right, I have two follow-ups that go in different directions. So I'm going to start with one arbitrarily, and then hopefully I'll remember the other one when we go off on a tangent on that. First one, if you're ever interested in getting that sort of modularity boundary without having to write out types, Rock used to have exactly that. So we had this concept of private tags, and basically they worked like tags and tag unions, except each tag started with an @ symbol. And what the @ symbol meant essentially was this is a quote unquote private tag. And the rule was that if you're inside a module, which I understand that you don't have concept of modules right now, modules being defined in Rock as like each file is its own module. The rule was the private tag namespace is associated with that module. So for example, if I say @foo with a capital F, that refers to my current module's private tag namespace. And so if I expose a function from my module and somebody else tries to use that, they can't use @foo in their module to sort of unwrap that and pattern match on it because it's a different @foo because it's in a different module. And so this was a way that you could have a Rock program with no type declarations anywhere and still get that. The reason we changed that was specifically because we introduced ad hoc polymorphism in the form of abilities. And in the case of that, so for example, going back to like hashing or JSON serialization. So if you want to say, for example, that my new custom type that I'm creating called foo, that type has exactly one implementation of hashing. And that implementation is associated with that. That can be potentially important for things like I don't want to have to worry about if I have my dictionary exposed, like, oh, give me a hasher for this type every time you construct the dictionary, then now you can get like, I call it with two different hashing functions accidentally, but with the same type, and now there's incompatibilities and stuff like that. At any rate, we wanted to introduce the concept of this type only has one implementation of this ability for it, and because of that, that was what motivated us to say, okay, we're going to get rid of the private tag system, then we replace it with our current opaque type system instead. In order to use that language feature, you do actually have to write out the type. Fair enough. So just wanted to put that out there. If you're interested in having a way to get modularity without having to have type annotations, there is a way to do it. And you already have the baseline feature that you need for that, which is anonymous algebraic data types. So if you want to introduce private tags or something like that, now you know about it. Yeah, I'm happy to talk more about that, offline. Anyway, okay. So second thing is that, so when it comes to modularity, something that I think is really interesting is I think there's a parallel between modularity and type annotations. And the parallel is that in both cases, they are in part a communications tool. So you gave the example of if there's a new version of the hash map or the dictionary or whatever, and somebody writes a blog post, you can choose to upgrade to that, or otherwise, why would you have a reason to upgrade to that? Which I think is a fair point. The communications tool to me is in part saying, hey, if you're going to use this thing, I really, really don't want you to depend on these implementation details because future versions are potentially going to change them, and I want you to be able to upgrade in the future. Now, one way you can do that is you can just put it in the documentation, and you can say, we don't have a concept of modules, but if you read the docs, you'll see, please don't depend on this thing. Or you can have a convention, like, if it starts with an underscore, that means it's private and, don't mess with it. But the stronger convention is to say, like, this is an actual module boundary and you'll get a compile error. Similarly, in my mind, it's analogous to the, like, a type annotation is a stronger guarantee and a stronger communication tool about, like, what's actually going on, with this type than putting a comment in, as a documentation thing. So I don't know. Maybe we see those things differently, but that's part of my view on modules.
I think I agree with. I definitely agree with the premise on, like, the communication and it's useful to have these things when so people don't get blocked from upgrading. I do think that I'm being almost deliberately counter in some of these things because I just want to stretch how far the hashing option goes, because I can upgrade the module, like I can look at your new thing, and if I relied on the old function, I can just pull the hash of just the old function. And I have moderately efficient kind of deduplication between the code, so I rely on the new version of your module, and one function from the old module is not a problem. I have quite a nice demo where I write code, and so I write code in the notebook, and at the top of the notebook, you have the hash for the notebook. But if you copy and paste that hash and use it in the code, you're just referring to, like, a previous version. So you can now do this fun thing where you can just kind of call functions from the last version of what you were doing. So there's kind of clever things. But I think the communication thing is real, and you don't want people to be stuck on an old system. But I think when you can pull in tiny fragments and you have a different, because, like, I've broken down the module into smaller boundaries, but I've also got rid of the concept of a package. I can zoom in into someone's package and go, yeah, I will have this function. They did a really nice, left pad, classically. And I have that. But once I have that hash and it's in my thing or it's in my cloud storage, it's never going away. And it's also, like, reducible. And, I can expect that in my editor. I can open, like, my database file which says the hash of this function, and I can just go, well, it's actually made up of a map of, like, it's a library of other hashes. I'll take the smaller one. So I think you definitely don't have the problem of being blocked from upgrades. Like, that's a non-issue. Whether you have this kind of horrible other problems of kind of, like, you've combined pieces of code that no one's ever seen before. One of the interesting things about reducing to structural types is you have this fun challenge of, you can't give names to something like an email type, for example. You can't have a more specific version of string. So you might end up with this library which goes, okay, first I validate the string that it is an email, and later I do things with it. Like, if you mix and match these, you'll have a less fun time. But this is another one of these. I'm not sure if it's an issue, because you won't have a crash. You'll just have some, like, unexpected behavior. Sorry, as in you'll have behavior that is understandable to the user that it's wrong, which I think is true for all type systems. Like, again, this sort of, if you give people who are not deep in, like, programming law some code and it says undefined is not a function, they get very angry. But
I've been there.
Yeah, but if you see that it calculates the maximum and not the minimum, they go, yes, this is that's back into my domain, and they can start asking useful questions about it. So you get this, it changes. You don't have computer problems, or, like, you don't have detail problems. You have different problems, but, like, you're not left kind of scratching your head in the same way. I'm sure there's another horrible mistake that you can have with composing these things, but it's definitely different ones.
Yeah. Speaking of like error handling and domains and stuff like that, something I saw on the EYG website was a mention of it was kind of an offhand mention, but about, like, division by zero and making that be something that is sort of a checked error as opposed to something that can, like, crash if it happens. Rock used to have that, and we moved away from it. But I'm curious, like, what your thoughts are around having, I guess, division returns a result or an optional or something like that.
No, just because the effects are really cheap. Well, I'm not even sure I implement. No, I do implement division. Let's just double check this. I think right now I just throw the abort effect. So you don't like it's right. So I've kind of, this is one of the big design spaces on like, because the effects are so cheap, do I lean into returning results as a default behavior, or do I actually lean into just using abort? And I haven't entirely decided, but division by zero is such a classic one of like, it's just painful to have results at this point that I've lent on throw an abort type. And if you really care, like if you really, really need this to not like happen, well, you can inspect where the abort type is coming from. So you can either, because you can handle all the effects. So you can build, I don't know if just throw in the whole concept of like Erlang supervision trees, but you now have this kind of concept of like error handling as in the type system. So, I don't want to inspect this library. I know it could abort, but it's probably some assertions like, they're checking that this list is, they're asserting that this list is always non-empty, and I believe them, right? So I just have to do something to handle the abort, which might just be like log and exit the program, or it might be like close this request handler down. But it drives you into doing like error handling strategies. And so the zero thing, you could write a really small function around it, which was called safe division, and it would then return a result and not have the abort type. But I think in a lot of cases, or maybe in a lot of cases when you're on the server and you have a big beefy box, which I think is kind of the context we talk about and we don't realize the assumptions we're in. You sort of, in these contexts, you have a bug tracking software and you have the ability to do abort. Like, this kind of log effect, this abort effect, this file system effect become kind of free. I think it's very likely that you have them. The power of making them explicit is if you take them away and you want to write a tiny embedded thing or this crazy Jira program, like they show up. They raise their head and go, I need being dealt with. But no, I mean, there's absolutely no problem for you like taking the abort effect in the Jira program and putting a top level handler that goes, if it ever aborts, I'm just going to write the content, something bad happened, into the ticket value. Say, that's what the program does, and it's not very helpful. And these programs who write small programs might want to understand like better error messages over time, but they're never just scratching their head going nothing happened, or they're never scratching their head looking at a thing going Stack Overflow or well, maybe not Stack Overflow in this case, but zero division error unsupported. Like it's always something that they did. The error message will always be greppable into their source, like into their code. They'll always be able to go, it says something bad happened, and they can control F something bad happened, and like, oh, we catch these effects at this level. And if they ever get rid of that handler, the editor will go, well, it'll point you to all the places. Like to find it is incredibly fast, which is what drove me to effects in the first place. Is if you take away this, we'll let abort effect happen, like you turn it off, you get little red squiggly lines at every single function call, which might, right. You just go here, 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 here. Because I've more than once had with problems at work where, I think I've mocked something for testing, but then there was a sneaky other way at access the network, or sneaky other way at access the file system. And you just sit there going, well, I can't grep for like file.read because actually it used file.read bytes or something. It's actually quite a like tricky problem. And you start trying to second guess function names from your standard library. Whereas actually with effects, you just go, here it calls the network, and it shouldn't. Okay, maybe it'll be hard work, but I know where to start immediately.
Yeah, in the case of Rock, the thing that we're moving towards, it's not shipped yet, but for things like that is making a system for testing where essentially, all of the effects that you want to be available in your test, you have to specify them at compile time. And you can specify fake implementations that don't actually use the network or something like that. But if your code is doing network requests at any point, it's just your code won't even compile, your test won't even compile if you have not specified what happens when a network request happens. So the goal is that you can make it completely deterministic, make it so the test will never fail and will always give the same answer given the same inputs, and you can simulate whatever network behavior you want. But you don't have to go hunting for like, wait a minute, what if it does network stuff? Let's defensively mock lots of things, or potentially have unpleasant surprises when something starts using the network and we didn't know that we needed to update our test or realize that.
I think it's a fun branding option as well, because there was a point when I was telling people about Gleam, like it'll never crash, the type system guarantees it'll never crash, and then you kind of go, but there's an assert keyword and there's a panic keyword. So you don't know that it won't crash. Like
right.
There's probably a comment or anything, but you then, this really quite powerful kind of marketing thing of like it'll never crash is just technically not true. And you only have to be bitten once and go, you said it would never happen. Whereas once you have this like effect version of it, I've written some fairly basic handlers. Because when you want to prototype quickly, you don't want to have to deal with everything. Like when you prototype quickly, you put this assert thing, which throws the abort effect a lot of the time, and you have a handler at the top. But when it does go through that handler and print out the stuff, you either just comment it out and go, okay, I'll start investigating. Like you always did it. Like you actually, that it will never crash. Like marketing spiel survives. And you haven't lost much because the quick and dirty, like I'll just use lots of aborts and have an abort handler is available to you. But then you're like, okay, this is now going in the missiles. Take off the abort handler and like work through it. And you can kind of do stuff. You can kind of go to like people and go, oh, there's 5 places it uses abort. This is going to take us some amount of time because they can ask you tomorrow. I'm like, I've cleaned up 3 of them, but 2 of them remain. And it's just a really useful discussion space. I think effects are coming. This is actually a thing I tell a lot of people. I think between Coca, Unison, Rock, EYG, I think effects will arrive near the mainstream. I mean, we can't call Gleam or anything mainstream, but functional languages will get them, I think, quite fast because they solve a lot of problems.
Well, it's interesting to see the different approaches. So like the way that Rock does it is with the platform concept and just like task as a type rather than having like an algebraic effect system. Unison is doing it in a different way with what they call abilities, but we call abilities something else.
Yeah.
And then EYG is also taking a third approach where they're not in the annotation at all, which is I think also distinct from what Unison is doing. So it'll be interesting to see for sure, like how these things kind of shake out. But I definitely agree that there is value in being able to represent these things as like a first class concept and not just having like, I mean, today most languages just have side effects everywhere. So this is like 2 steps beyond that. 1 step being you have a separate concept for effectful code versus non-effectful code, which I like to call managed effects. So I actually think that a way that I'm going to start trying to explain that and just see how it goes is basically, what if every single effect that you had was like async await style? Because I think a lot of people have a mental model of how async await works. And I think it has basically the same characteristics in terms of like it's not necessarily asynchronous. Now in Rock's case it is, but I realize that in your case it's not. But it does give you the same mental model of like, oh, I know that if something starts doing an effect, now it needs to be async, and that means that all of its callers need to be async as well. And also when I call it, I don't just call it normally, I call it with await. And then there's a little bit different syntax in Rock for that, but hopefully it'll get people an intuition for that rather than, I think the traditional way that we've talked about pure functional programming is, hey, everything is pure functions, and people are like, great, so it just heats up your CPU. And it's like, no. There's this whole IO monad, and it's like that whole thing has just not gone well, I don't think. It's so I'm curious to try the explanation of like if somebody's coming from an imperative background, it's like, in this language, all effects are async await. It's not just the asynchronous ones. Like there are no synchronous IO functions. There's no synchronous effects of any kind. And one argument for what's nice about that is that it means that you don't have this bifurcated ecosystem that everybody ends up with when they have like async await, where you have like the async version, you have the synchronous version, and then like it adds a lot of complexity that if you just had the async version kind of goes away. I wanted to go back to ad hoc polymorphism. So we're talking about sort of like Rock changed from private tags to opaque types because we wanted to introduce stuff like hash. And I kind of glossed over it, but at the beginning you mentioned that like JSON encoding and decoding and like, I'm assuming you meant typed functional languages, historically has been annoying. But actually, this was one of the motivations for introducing abilities, is that we actually now have a system that is very nice. And I don't know how it would necessarily work with EYG. I guess if you're okay with not letting people define their own implementations of this, maybe it's fine. But basically, we do have the characteristic that you don't have to write any type annotations to get essentially the equivalent of JSON.parse in JavaScript and JSON.serialize in JavaScript, with the exception that, unlike JSON.parse and unlike JSON.serialize, if there's any kind of error, it happens right at that call site rather than like secret undefineds permeating through your program and maybe causing problems later. which I like to think of as kind of the best of both worlds, as long as you don't want to do something that's super custom. Like in the very common case where you're like, I just have a record, it has these fields, I just want you to turn that into JSON or get it, read it out of some JSON. I gave a demo, it's like pinned on my Twitter profile, RT Feldman, that of me like walking through some live coding of Rock, and I demonstrate doing this, like just making some like JSON decoder where it's just like, user equals and then like decode it, okay, and then I don't need to say any type annotations. And I think at that point in the live stream, I hadn't written any type annotations yet. So I think that would fit with your design goals if you wanted to implement a system like Rockability's with, and that's not specific to JSON. That was it's just arbitrary encoding and decoding, and then when you call the decode function, you have to specify I want JSON, I want XML, or whatever. Yeah, so I don't know if that would be interesting to you, but if you want to talk about that, it's also something we could follow up about with later.
No, I think the JSON decoding problem, I think there's a lot of stuff about this, because this functional programming, and when you get to the edge, it starts becoming gnarly again. I think there's probably 3 or 4 ways I've tried tackling JSON decoding. One of them, there is an acceptable builder API, but that's just you write it by hand.
Yep.
I tried doing some stuff with almost like data log constraints, so you would decode it into almost like a database of triples, which was wild and beyond slow, and like so slow that even I couldn't like tolerate that as a way of doing things. There was an approach with type providers in an early iteration where you say like, which is, so they were successful, but type providers haven't survived into this version of the language. They were a fun experiment. But the thing I've kind of settled on now is, so I have, so in EYG you can run it before type checking it. So you can look at it in the type checking and go, this is terrible, and then you can run it anyway, which gives you, and then because you can serialize functions and ship them around, you have this ability to have a kind of a typed space extend over the build script and the server script. So you can write a bunch of code, and you can compile to say Erlang this continuation, and it uses this is the closure serialization. But one of the things you can do in this build script is you can look at, say, a JSON spec or API, Swagger, Swagger specification, and you can run this in untyped checked code, and it can look at the specification. So it can generate the AST for a function which will decode JSON. Like it can build the decoder that you want in the build script, and then this can just be passed in scope into the server function. And the type checking a function is available in the language. So there is a built-in primitive called like type check, which you can pass a function to. So you can type check this function with these effects. So you can build something on the build script, because one of the things I always say about build scripts is, in a build script, something failing at compile time or runtime is the same time, because you immediately just run it locally. So I don't bother type checking there. So you can do this unsafe stuff to build a decoder, just pass it into the server function, and then you run the type check, and it goes, yeah. All through your code, you assume that this thing is returning an object with, a name, age, and location field. And from the API blueprint spec, you generated a function that returns such a thing. So this is quite a nice solution. So you can now libraryify, you could have a hash, which was the library for the API blueprint to request decoder like function, and you can just use that. So you don't need to. There's no more magic in the language. You don't need to put anything else into the language. I kind of like it. It's a bit of a mind bend that you can use this concept of like just continuing the program from the build scripts on the server. And if you really start messing around, you can push this further. Like you can do the same thing for when a web request comes in. Like just take this closure, serialize it to JavaScript, and put it in a HTML page that you send back to the client. So you've now got 3 levels of nested functions that just run from build script to server to client. But in each case, you can kind of compile a regex, do some stuff with building like. The one thing you do need with this is you need an external source of truth. So that's the main problem with it is the program, if you use so in Rock, I think you were saying that if you have a user type which has these 2 fields, and you call the automatic JSON decode it, like the type in the program is the truth, saying there must be a name and an age field.
Well, you don't have to define the user type, right? It can also be based on type inference of how you used it. So like if you,
okay, right.
Yeah.
But the program would provide the truth, whereas this would need an understanding of something ahead of time when it ran that build script to give you the AST that it passed around.
Sure.
And I like externalizing the source of truth, but it's not for everyone. And there's definitely programs which are quicker and dirtier than that, where you're like, yeah, it's just the program is the truth. There is nothing else. But that's never true for an API. That's quite nice. Like, it's, if you want to integrate with APIs, like there's somewhere they've written it down, like what it should do. Maybe not very well, but they at least tried.
Something that this reminds me of that we talked about doing in Rock but never actually implemented, mainly because it was more of a like, that's kind of cool, than like that's actually a practical thing that we should do, is it's possible, if you want, to create a type-safe eval using like the things that we have here, where you're like, okay, I'm going to say foo equals eval, and then you just have some string, and then basically you can use type inference to know ahead of time, based on how foo is used, here's what the type of foo needs to be, and then you can basically make the eval say, I'm going to run this thing, and then if it gives me back, or I'm going to compile this thing actually, if it gives me back the correct type based on the usage, then we're good. Otherwise, give an error right away. And so that feels like a use of eval that I have not heard of before, where you would evaluate it and then immediately get either a type mismatch, just as if you were decoding JSON, or not. But of course, to do that, in Rock's case, that would mean you have to ship the entire Rock compiler along with every program, among other things, which is not necessarily something that people want to do. And also, I mean, it's for eval, so is that even something people want? But it's funny to think that you could actually do that.
So I listened to this episode when you brought this up, and I meant to... I think what you describe as type safe eval is what I understand to be type providers. So it's basically, the type provider occupies some hole in the program, and this must return, say, a certain type, and then it's going to run some code that has to return that, and it'll, running the type safe eval itself returns a result because you may have put something in that is not. But so when I had type providers, so type providers were they were a while ago, and they were an incredibly shaky implementation, but I did manage to do a demo of type safe upgrading of code, because if you have, say, an Elm style loop where you have a handle function for messages coming in, one of those messages can be like hot code upgrade, and which just takes in a binary, a string, and you can pass it to the type safe eval. So the type safe eval knows that it's a compiler or an interpreter or a pass, whatever it's doing, takes this binary, and it has to return a function that can be used as the next version of update. So
interesting. Okay.
And so now you can. So I made this demo work where you had a web server that you could send in type safe. Like, it would give you a 400 response going, "You've sent me a program that is not a type safe upgrade of the program I'm currently running," and it's wild that you can now get to this point where your types can kind of extend over time.
Right.
But this is where you need the structuralness, because your names in one compile, like nominal types, you don't know if the names mean the same thing. You have to throw away this concept of named types to get there. But once you do, you can have type-safe upgrades. And once you have type-safe upgrades, you can deploy on a Friday kind of thing. Like, it's I would love to get this feature reworking again, but the amount of machinery, yes, you're right, you have to have the whole compiler available at runtime in that target. So you end up kind of compiling it twice. You're like, my build tooling is this, everything's written in Gleam, but I'm trying to run it on the back end, which doesn't have the Gleam stuff, and it's all proven possible, but there was a lot of kind of just massive warts. Like the interpreter and the type checker was 90% of the code I was shipping to the client.
Yeah, I could see that. Well, another interesting thought about nominal types, where the type has a name and has a distinct meaning from other types that happen to be structurally the same, but don't share the name. Especially as it pertains to upgrades, is the question of, have the semantics of this thing changed even though the structure is the same? Like, for example, you can say, well, the structure, the type of these things are exactly the same, but the way that I populated the contents of those structures changed such that now the contents are incompatible and the functions running on them are expecting them to be in a different format or something like that. Like, you had an integer that used to represent an index into something, and now it represents an index into something else, or vice versa. That type of thing can be, in my mind, kind of a scary thing from an upgrade perspective, because it's like, well, I can, as far as I know, safely deploy this thing on a Friday, but then it turns out it was just, no, I just didn't actually get any help from the compiler telling me that these things were, incompatible. But that, having said that, I don't know that there is necessarily an easy fix for that in terms of the like the opaque types problem, short of doing something like doing a hash of all the implementation details of all the the opaque types contents and deciding, well, actually we know for sure that this thing, the API has not changed at all, and therefore it's safe to upgrade this thing in place. But that's obviously a pretty deep rabbit hole to go down.
Yeah, and I've just managed to swerve it by the program never gave you any ability to define something nominally. Like it wasn't, you never have semantics beyond the structure. And this is kind of one of those, the EYG thing, like name, like eat your greens. Like if you lean into a world where there's no meaning beyond the structure, you get this for essentially free, because you have a global namespace over all time of just like structures like this can go in these functions. Like period. Doesn't matter where they come from. Obviously, giving meaning to your types is an incredibly useful design feature. So which one do you want, kind of thing?
Sure.
Is the choice at the moment. Yeah.
But I think this is an underrated design choice, of saying essentially like, we're explicitly not supporting this feature, and so as a user of this language, you need to be aware of, like, here are some of the pitfalls and downsides and so forth. In my mind, that is in some cases better than sort of trying to paper over problems and pretend they're not there and giving you sort of a false sense of security. It's almost like, okay, on the one hand, if you're able to provide an experience, which of course has its own trade-offs, of you can safely walk down this street and there's no chance that the ground is going to collapse under you. Great. That's wonderful. Yeah. Maybe there was a cost to that doesn't make sense, but it is a nice experience. But if there's a chance that the sidewalk might collapse, I would sure appreciate a big bright warning sign that says, hey, be extra careful here. Don't walk at a normal pace, pause and test things out with your toe. If you start feeling the ground being shaky, maybe, take a different path. Versus like, just you have a sidewalk that is actually dangerous, but there is no sign. So I think, someone who's hearing you describe this design decision might think, oh, that's, I would much prefer to have, some version of this that has nominal types or whatever, even in the context of upgrades. But I think there's something valuable to saying, like, explicitly, no, we don't support that, and you need to be careful. Like, if just because the types are the same, you're not going to get a warning, as opposed to giving people a false sense of security.
Yeah, I'm very suspicious of things that mostly work. So like, you could definitely write a system where you had nominal types. You look at the fields and you go, if they're the same, I'm going to assume it's the same type. But then you get to a situation where someone's like bank number was a string with typed as, and someone else's email, and you put them together. So it feels, it's kind of like the RPC promise, like, oh, it's just like a local method call, unless the machine's not working. But most of the time the machine works, because you then, you only ever see these problems when it matters, or when you've like dug into not looking for them. So it's definitely cheating by going, we never gave you that guarantee. But no one who ever wrote a single EYG program has lent on there being an email type, like as an alias string. It's never been possible. But yeah, because I think there are projects where people try and do kind of automatic upgrades, I think like Lambda on Elm and these kind of things. And they are fascinating projects, but they do have to. They at least, I'm sure there's probably ways to do them consistent, but you have to write down or describe what your consistency thing is. And it's not the consistency you started with when you just had nominal types in one compilation run of a program. It's definitely something new. And it might, maybe there's good things, but it's definitely new.
Nice.
Yeah.
Awesome. Well, is there anything else we should talk about? We covered a ton of ground.
No, I think we've been all over the place. I think this has been fun. Yeah.
Very nice. Well, thanks so much for joining me. I really enjoyed talking about EYG, and really appreciate your taking the time to chat with me about it.
Yeah, thanks for having me. Cheers.
That's it for this one. I hope you liked it. You can find links to some of the things we talked about in the show notes, and if you've been enjoying these episodes, consider supporting the show on Patreon at patreon.com/softwareunscripted. Until next time.